turgor movements are seismonastic. These movements are observed in the sensitive plant like Mimosa pudica. Owing to its sensitive to touch, it is called as sensitive plant or touch me not. It is herbaceous with bipinnate leaves. At the base of the leaf is swollen is called pulvinus. Similarly, pulvinules also present at the leaflets. In case of pinnules, touch, burnt or blow or cut, the stimulus is conducted at the base, then other pinnules. The stimulated pinnules get closer in pairs and drop down in succession from the tip backwards. The stimulus passes through the other pinnules where the same happening is repeated. If a stimulus is strong, the whole leaf becomes affected and the whole leaf bends down. A fast stimulus travels with the speed at 20 centimeters per second. Thus, the entire movement is very rapid, taking place in few seconds. The movement is caused by the differential laws of Turger on two sides of pulvinus. Two sides of pulvinus show different type of cellular organisms, of which lower half consists of thin-walled, loosely arranged parenchyma cells with large cellular spaces, and upper of a bit compactly arranged parenchyma cells. As regards to sensitivity, the upper side, the vascular trace passing through this region shows upper side stable, lower side sensitivity. During normal conditions of the both sides of pulvinus remain fully turgid, the leaf held erect. The stimulus reaches when in pulvinus active water enter into the cytoplasm of the cells which are present on lower half of lowering the osmotic pressure of these cells effective and forcing out the water into the intercellular spaces. Cells now fail to hold the pinnules erect and cause dropping down the pulvinules and ultimately pulvinus. And the whole leaf bends down and pulvinus and pulvinules act as hinges. Like doors and windows closing and opening, no, like this. Stimulus may pass from one leaf to other. It is believed that whole mechanism operated under influence of some hormone which produced in the stimulated part travels to the pulvinus through the xylem. The reverse is case true for restoring the normal position. Growth movements divided into three subgroups. One is namely tropic movements which are related to directed towards the stimulus. Second one is nastic movements. The response has no relation to the direction of the stimulus. Nutation is a movement which is usually independent of environmental factors, most commonly found in radially symmetrical parts of the plant such as roots and stems. Dropping movements are curvature movements due to stimulus coming from one side. These movements controlled by the direction of the stimulus occur in one direction. Two differences in the rates of growth on two sides of moving organism which results in curvature. A tropic movement may be phototropic which responds to light, geotropism which responds to gravity, chemotropism which responds to chemicals, hydrotropism which responds to water, aptotropism or thigmotropism which responds to the touch. Phototropic or curvature movements that takes place when the plant exposed to the natural light or artificial light from one direction. If curvature movements towards the light, that is called as positive curvature. positively phototropism, and if away from the light, that is a negative phototropism. The leaves of some plants keeps themselves perpendicular to the light or diaphototropic. One example are the leaves of the Neptunia oleracea, which keeping their faces toward the sun upon moving throughout the day, turning from east to west. The flowers of Ilianthus annuus also moves same way. The flowers of Ilianthus annuus also moves the same way, always keeping their faces toward the sun. Arachis hypogea also shows different type of phototropic movements during different phases of its life. It is positive phototropic when they ovary unfertilized, but after fertilized ovary, it becomes negative phototropic. With the result, it moves bends toward the soil. Dispersal of spores in Pilobolus, a fungus, occurs when the sporangium have moved towards the light. The phototropic movements thought to be controlled by a growth regulatory substances which collect on side away from the light to increase its growth and result in curvature. In laboratory, we can be demonstrated the phototropism by keeping the potted plant inside the box with a small opening only on one side to provide the light. After some time, it will be found that stem has bent down the opening through which the light is coming. Geotropism. Geotropism is a movement caused by in response to gravitational stimulus. Geotropism can be observed roots of many plants and negative geotropism in their shoots. The secondary branches of roots and stems are diageotropic, plagiogeotropic, or apogeotropic. As they grow laterally at the angle to the gravitational force, ageotropic or tertiary. The flower stalk of poppy flower shows different responses to the gravitational force in different phases of its life. It is positively geographic and keeps the unopened bud hanging downwards. But as the bud opens, changes into flower, it becomes negative geotropic. This is the result that direction of the stalk changes and the flower grows upward. The change in the direction occurs due to unequal growth on two sides of stalk. Depending on the contour, many plants grows horizontally in soil due to some reasons. Charles Darwin proved that if the root or shoot tip cut off, there is no response to the gravitational stimulus, which when grows in culture media moves and grows. Thigmotropism is a movement of curvature of the plant response to unilateral stimulus of touch and can be observed in so many twinners and climbers. Whenever whenever supporting organ touches a support, it makes a curvature movement to catch hold the object and tightens its hold. In tendril climbers, the tendrils first show nutation, and as soon as its apex touches the support, it makes a thigmotropic movements to turn around it. Chemotropism is a movement caused due to unilateral stimulus of the some chemicals. The pollen tube in many cases moved towards the ovary. Some chemicals is a good example, and another example can be that of fungus mycelium grows in culture media, moves and grows where the region of medium where more nutrients are concentrated.
Hydrotrophy. This is the movement of the plant organ to unilateral stimulus of water. This is also results in curvature of the organ concerned due to unequal growth on its side. What is the picture you are seeing in front of you? Root coming out of the pot and searching for the water. The demonstration of the hydrotropism is possible in the laboratory with the help of a shallow sieve in which moist sawdust is kept and some seeds are germinated. After some time, it will be observed that the radicals come out of the holes due to positive geotropism, but immediately after coming out start bending up and re-enter into the moist sawdust through the other neighboring holes of the sieve due to hydrotropism towards the water. Roots are positively hydrotropic.